All right. Hello, everyone. Thank you for taking time to join in this very nice, bright afternoon. Uh, so before we start the seminar, I wanted to remind everyone that the session will be recorded automatically. And during admission, you are all muted. If the speaker is okay, you would be able to unmute yourself and ask questions. If not, typing it in the chat window and I will monitor the chat window for you. And if you're a registered participant, you will get a link to this recorded session as well as the slides and a small seminar feedback survey after the seminar. So today we have Dr. Stephanie Lanza from Biobehavioral Health at Penn State. She has different areas of research, but is more devoted to prevention research with the focus on extension to latent class analysis and translating time-varying effects models. Today, we're going to hear about the latter side of our research, I suppose. And without further ado, I'm going to let Stephanie take over.
Great. Hi, everyone. Thank you, Pravani. It's really nice to be here. I believe we have an hour together, and I'm a very informal presenter, so I'm happy to have you unmute and ask questions. I will also try to keep an eye on the chat window. So let me see. I'm just trying to share. Here we go. Okay, let me get my chat window going. There we go. Does that look okay, Pravani?
Yeah, yes, it looks great.
Okay, excellent. All right, so let me just organize my windows here. Great. Well, so happy to be with you. I've been at Penn State since 2004, so I see a lot of familiar names on here too. I'm familiar with some of the KL2 program at CTSI, and just really happy to be here and have a conversation today and just add something to your repertoire that maybe you haven't heard of before. So what I'm really hoping to do today is I want to discuss time-varying effect modeling to study developmental and dynamic processes. And if this is not a technique you've heard of before, I'll be very introductory, and it's a very direct, simple extension of linear regression modeling. So it should be pretty easy to kind of grasp. And my hope is that if you haven't heard of this before, by the end of the hour, you will have a sense of whether or not TVEM, time-varying effect modeling, might be useful in your own work. So with that, we'll just get started here. And so first, I'm going to give you a little bit of a background about TVEM, time-varying effect modeling, because it was really born here at Penn State, and it's kind of fun to talk about its evolution, if you will. And then I'm going to present two examples today. One related to nicotine addiction and one related to adolescent vaping. And my work has been funded by the National Institute on Drug Abuse, which is why I have drug examples here. But the method is completely agnostic, of course, to the topic, and hopefully might be useful in your own work. This first study, we're going to be analyzing intensive longitudinal data. And in the second study, we're going to be analyzing cross-sectional data, actually. So I'm just trying to give you a little bit of a hint of how TVEM can be really flexibly applied in practice. And I'll just end with a few resources that if you'd like to learn more information, you have somewhere to go. So let's just hop into the background here briefly. I really approach my quantitative work with this idea. I'm a human behavior scientist, and I understand that behavior is complex, which has driven my work in latent class modeling. And human behavior is also very dynamic, unfolding over a variety of timescales. And so this orientation toward understanding the complexities of human behavior is relevant for understanding the behavior itself and how that changes, say, across age or across real time or historical time. Also changes in processes that might unfold over time, And if we introduce some sort of behavioral intervention, interventions typically, we're humans, we're complex, and it's not like we turn a switch. Turn a switch and the intervention is on, and the effect is on, and it's steady. The intervention effects can also vary over time or with age and so on. So here's just a quick motivating example. It's a little bit trivial, but let's think about this for a minute. We know that negative affect and craving to smoke, negative affect and craving to smoke are tightly linked among addicted smokers. So again, like you get in a bad mood, you crave a cigarette when you are an addicted smoker. So what does recovery from smoking look like? So TVEM can answer questions about such processes. So for example, we could address the question, is negative affect differently associated with craving at different points in the cessation process, right? Smoking cessation is a process in itself. Things are shifting with time. So here's a simple thought exercise. Let's suppose we intervened, we did a behavioral intervention to reduce risky alcohol use. Maybe it's for college students. And we have a 2-arm trial. So no intervention or behavioral intervention to reduce risky alcohol use. So we would potentially get a baseline measurement, run the intervention, and then we might get one time point after the intervention to see if it worked. Or maybe we assess our participants twice after the intervention to see if it worked at those 2 times. Or maybe we assess it many times after the intervention has been deployed, and we think about time as a moving window when we think about evaluating our intervention. So what would that look like? So let's say we have one time point post-intervention. So we've got the placebo group is in a triangle, and our intervention group that got the behavioral intervention to reduce risky drinking in this lighter blue square here. And so our post-intervention time point, we might estimate the prevalence of heavy episodic drinking at, say, this looks like 0.46 for the placebo group and maybe 0.26 for the intervention group. And if that difference is statistically significant, we would say that our intervention worked. Great. That's assuming there were no, baseline differences. We did randomization and so on. Let's say we went back and assessed the same participants one additional time after the intervention. So this is time 1 after the intervention, and here's our 0.56 and 0.26. And let's say a month later, we reassess the same participants and we see the effect shrinks a little bit. So in the placebo group, the rate of heavy episodic drinking goes up a tiny bit, but in the intervention group, it actually goes up a more significant amount. We see a closing of the gap. That is a hint that maybe the intervention effect is time varying. Yeah. So let's expand on that. So those were the first 2 time points. Let's suppose we went every single month for 10 months. We assess the same people. Then we might get a little bit more of a window into the time varying effect of this behavioral intervention. So in this case, we see a strong effect in the beginning, a closing of the gap. And for whatever reason, we maybe see this kind of sleeper effect of the intervention. Maybe that's when they branch off and go off to spring break, and the intervention somehow is active at that time. So again, we could identify time periods during which an effect is more stronger. So that's just an example, a thought exercise, if you will. So what is TVEM? TVEM, time varying effect modeling, is a really simple, intuitive extension of linear regression. So, so if we're collecting longitudinal data, we're typically collecting it because we think that behavior or our outcomes are going to change over time. And maybe we think that there's a process that's unfolding over time. Well, it is therefore natural to expect that both our outcome of interest, maybe in my example, it was the heavy episodic drinking, the outcome will change over time, But it may be very plausible to assume that or want to test for whether associations between variables or relationships between our covariates and the outcome may also change over time. So TVEM is designed to evaluate whether and how effects of covariates or associations between variables change over time. That's really in a nutshell what it is. And so let's think about regression for a minute. Regular old regression, we all know and love. It's the foundation of so many statistical models. So this regression equation it models our outcome y as a function of an intercept and the effect of x. So in this case, we have one predictor x predicting the outcome y. If we make an assumption here that this effect of x on y, or our slope, or our beta 1, is the same for all people. We don't have any moderators in the model or anything. But so we estimate this as a function, y as a function of x. TVEM allows such coefficients, like the slope for x, to be expressed as a function of continuous time. So this slide presents to you the mathematical underpinnings of TVEM. It's really this simple when you look at the model. So we are now allowing our coefficients to potentially be estimated as a function of time. So now we have an intercept as a function of time, and we have a slope, or for x, as a function of time. Okay, so we'll unpack this a little bit more, but in a nutshell, this is all TVEM is. It's taking linear regression, and it's allowing us to estimate our coefficients, our regression coefficients, as a continuous, nonlinear function of time. Okay, so in TVEM, we estimate these coefficients, so we no longer have a single number summary to say the effect of x on y is this. Instead, we estimate it, if we estimate it as a continuous, non-parametric function of time, then when we're interpreting the effect of x, or the slope for x, or the coefficient for x, we have to actually interpret a figure. And so this is an example of what one coefficient result might look like. So this is a regression coefficient on the y-axis. And then, of course, on the x-axis is time. And we see in this hypothetical example that the coefficient is strongest at time equals 6. And it's actually weakest at time equals 1. And so we have to look at, visualize, and interpret these functions in order to interpret our regression coefficients. So again, when we're talking through this hour, basically time is always going to be on our x-axis until the very end of the presentation. So time will be on the x-axis. So let's just take a minute and look at the history of TVEM, and then just for fun, and then we're going to step through 2 empirical examples. So functional regression analysis has been around for a long time, was introduced in the early 90s as in the statistical literature. And when the Methodology Center was in the College of Health and Human Development at Penn State, Renzi Lee in statistics was closely partnered with us. He was one of our key investigators, and Renzi was interested in adapting functional regression analysis to address certain problems to modeling substance use behavior over time. And so, so building on this functional regression framework, Renzi expanded it and developed this product as a SAS macro. In my applied areas, most of the researchers at the time were using SAS. It's slowly shifting toward R, but SAS is still really popular. So that was in kind of the 2010s, and you'll see we had the macro software and a user's guide and little videos. And so we were starting to push this technique out so that behavioral scientists, social scientists could use it really easily, understand it really well. Then Renzi and I, along with colleagues at the University of Wisconsin, got an R01 and contributed this special issue to nicotine and tobacco research, where we were really trying to demonstrate methods for analyzing intensive longitudinal, like ecological momentary assessments for studying nicotine use and smoking cessation attempts. And so this was where applied research really took off with TVEM. So that was really fun. And then we kept wanting to do more with the technique. So in 2015, we released a greatly expanded version of our software that added random effects, robust standard errors, weights. I was interested in causal inference and at being able to incorporate inverse propensity weights in our analyses. And so we really pushed and got the weighting function added. So that was a nice extension. And then from then on, we've been really focused on applied use and application of TVEM. And there's no one model that everyone should use, but if we all have access to models that can answer different types of questions, then we can answer more questions with our existing data. So in 3 years ago, my colleague Ashley Linden Carmichael and I published this book with Springer that is kind of a comprehensive introduction to TVEM. And there's a corresponding website that I'll point you to at the end of the talk that shows lots and lots of SAS syntax for examples. Okay, so I just thought I'd kind of share that history and our gratitude to Renzi for his important statistical work in this area. Okay, let's go through the first example. Check one more time. Good. So we're going to first talk about nicotine addiction and the recovery from nicotine addiction, or recovery from when you're going through smoking cessation. So, of course, we know that tobacco use is a leading global cause of preventable death. It's still a quite important cause of death. This smoking cessation, if anyone has tried or knows someone who's tried, it's very difficult. Most people relapse by far. And withdrawal symptoms are a key reason why people relapse. And so we partnered with our Wisconsin colleagues who are smoking experts on this project. But we thought that an improved understanding of the withdrawal symptoms when you early in a quit attempt might help their group to inform tailored interventions, tailoring it to individuals and also to time in your attempt. So we got to use some really excellent data that they had collected. It was recently collected. They did their primary analyses already. The data were essentially on the shelf. And we thought, hey, let's dig into those data and see if we can learn something new using TVEM. So this was a really nice data set because it was so large. We had 1,504 daily smokers enrolled in this smoking cessation randomized controlled trial. So we'll be just doing a simple comparison today between the placebo group that got counseling only versus all the other treatment groups that received counseling plus 1 or 2 medications. So we're going to look at placebo versus treatment, which is counseling plus medication. So 2 groups in today's lecture. And this study was really novel in that for such a large sample of willing to quit addicted smokers, they all participated in this ecological momentary assessment study. So a real-time assessment of this dynamic phenomenon of smoking cessation, where your withdrawal symptoms are changing over time, your mood is changing over time, and your actual behavior and lapses are changing over time. And so here's an example of a display of the study design. So they had a lot of intake data collection. And then they started, this is the important part for us, they started 2 weeks before their target quit date. They started to provide EMA. They provided 4 assessments per day for these 4 weeks, week 2 to week 6. And then they had a target quit date in the middle there. They did 1 assessment upon waking, 2 random time points throughout the day, and 1 at bedtime. And at every single time on their mobile device. They provided information about their momentary withdrawal symptoms, craving, affect, hunger, whether they smoked since the last beep and how much, and their motivation to continue to be abstinent, things like that. And then they had long-term follow-ups as well. Okay, so the goals of this study, and these were published in Nicotine and Tobacco Research. So these were, I'm wording here the kinds of research questions that we contain in a single empirical paper. So this paper, this project had two aims. The first goal was to simply understand the underlying dynamics of craving during a cessation attempt. So just modeling the change over time during a quit attempt. And then in goal 2 was to estimate the effect of treatment, so treatment versus placebo, which was randomized, on decoupling craving from its key drivers, like negative affect. So again, remember, we know negative affect drives craving when you quit. When does that dissipate over time during a quit attempt? So that was, and so that was goal 1. And then does medication accelerate that? That was question 2. So I'm presenting the measures for both of these empirical studies because it's shocking what a simple little set of measures we use to gain such nuanced information in our data. So the measures in this study, these were intensively assessed 4 times a day. Craving, what's your momentary craving? And then we have and then we have, as a predictor, we have got your negative affect. So also intensively measured. What's your momentary negative affect? So we've got craving and negative affect measured intensively. We know at baseline, when they were randomized, their quantitative score for their level of nicotine dependence. So that is not time varying, but the effect can vary with time, right? The level of dependence at baseline may be predictive of some time varying changes. And then we have our moderator, which is placebo versus treatment group. So we have a binary treatment group, and we have our baseline nicotine dependence score, and then 2 intensively assessed variables. That's it. So when you're using TVEM, the first thing that I like to walk people through, it's useful to sort of talk it through, is what varies with time. So of course, we know how we designed our study and collected our data. So we know which variables vary with time. But when we're estimating our model and specifying our regression equation, now what varies with time? So of course, we expect that craving will vary with time. In this model, craving is our outcome, because we want to see if craving and negative affect stay tightly associated. So craving is our outcome. We expect that craving, on average, will change over time. We hope during a quit attempt, it will decrease with time. You'll see this by our specifying the intercept to be a continuous function of time. We know that our measured negative affect variable varies with time. And we want to see if the effect of negative affect, or that slope for negative affect, changes with time. That's really an essential question. Does the link between negative affect and craving change over time? And then we also want to see whether the effect of baseline dependence, which was only measured once, actually varies with time. So when you really think through which variables, which constructs change over time, which associations change over time, then you'll know exactly how to specify your model. And so in this case, we would estimate a regression equation that's predicting craving from person I at time t as a function. It's craving equals an intercept, and it's an intercept function, right? It's an intercept as a function of time, because mean craving changes with time. And the effect of affect on craving, which is beta 1, also is specified to vary with time. And then baseline dependence, DEP is dependence. That one is measured only once for each individual I, but the effect is it also specified here as being allowed to vary with time. So you can see it's powerful to think about, pay attention to your subscripts. What do you have repeatedly assessed and what don't you? But the most critical piece here is which coefficients do you want to allow to be estimated as a function of time? Okay. So here's a snapshot of some of the results. So this is just showing us the association between our predictor of negative affect and our outcome of craving. So this y-axis is now the effect of negative affect, the effect of NA, and of course over time. Now, when we're using TVEM, time must have some sort of meaning for us, right? Which means time zero has to have a specific meaning. In our case, time zero means precisely the day of your quit date. And so time zero is quit day, and we only used 2 weeks of EMA because the other 2 weeks were pre-quit date. And so what we see is that the effect overall, if you average the blue and the red lines here, which are for the 2 treatment groups, the effect is really pretty static over time. It's about a 1.5, a beta of 1.5. However, when we look at whether treatment moderates that association, we actually see the very first few days in the quit attempt, we see that the placebo group has a stronger pairing between negative affect and craving compared to the treatment group. So the medication does seem to be decoupling negative affect from craving, but only in those first 2 days. Okay, so maybe there's some benefit in this regard just right out of the gate when you first try to quit. In contrast, when we look at the effect of baseline dependence, again, averaging across red and blue, we see a pretty flat line, that the effect of baseline dependence on craving is pretty flat. But what we also see is that the placebo and the treatment groups diverge in the second week of the quit attempt. And so now we see that that treatment that helped decouple negative affect and craving in the first 2 days, we see that the treatment in that second week helps to reduce the effect of the baseline dependence level. So these are really nuanced intervention effects drawn from TVEM, but fit to a simple regular data set that had already been analyzed. And our nicotine research collaborators were excited to interpret what these might mean.
Stephanie, can I ask a question?
Yes, please.
So I might have misunderstood something, but when you were talking about the study design, so after they decided to quit, so day 0, right? I quit smoking today. And then if I remember, there was only 2 time points where you collect data, like week after and another week. So does that mean that they have cravings reported somehow for every day after they quit? Or are you doing some sort of like an interpolation, extrapolation type of a thing?
Yeah, so great. So we've got 4 times a day, every day, for the EMA segment in the red here. Sorry. So yes, so 4 times a day, they reported their craving and they reported their negative affect. And so we have 4 times per day, and we are analyzing the 2 weeks following quit day. Great clarification question. Anything else? I'll just move on to some of the implications that our colleagues drew from these results. And what I loved about this study is it pushed them, who they had designed this trial and run the analyses themselves for the primary analyses. And then we came in and said, let's look at things a little bit differently with time varying effects. And it pushed them to think a little bit differently about how they were thinking about treatment effects, because we could model them a little bit differently. And so it really pushed them to think outside of the box in terms of evaluating the effect of an intervention. So we concluded that with time, treatment changes the relationship or the association between baseline dependence and craving. And treatment seems to diffuse the role of negative affect, which is an important driver of craving, very early in the quit attempt. So those were some of the implications we drew from the study. But again, what I loved about it is it had an intervention scientist thinking a little bit more creatively about evaluating the effects of their randomized intervention. And then sort of broader implications, just as a reminder, we had a static baseline variable of your level of nicotine dependence, but its effect was estimated as a time varying effect. And we saw that the effect it varied over time when it was moderated by the treatment intervention. So the effect of the treatment may be time varying. Again, this is something that intervention researchers who design the trial might be able to posit more specific evaluation questions a priori that could be tested with TVEM. And then hopefully this kind of information can be taken together to inform ways to improve treatment outcomes for individuals.
Could you also include an interaction term between the predictors here, just the baseline?
Absolutely, yes. Great question. So you can absolutely have interaction terms. Yeah, we can talk more about that. Basically, anything you can specify in a linear regression model, you can do it here. And if the interaction terms are allowed to vary as a function of time, then that implies that there's a time varying moderation, which is quite interesting.
Stephanie, there's a question in the chat asking, when using this method with longitudinal data, is there an optimal number of time points that should be included?
Yes, thank you, Ryan. That's a really good question. That's a hard one to answer quickly. It really depends. So when you're thinking about something that unfolds over time and you have longitudinal data, I guess the first thing I would say is what is your time actually representing? Is it the individual's ages at which you assess them, which might vary across people, which is fine, or is it time in study? And it's wave 1, wave 2, wave 3, wave 4, which would be the same for everybody, which is also fine. And then you want to see, what is the speed at which you think your process is unfolding? Did you assess it intensively enough to capture any kind of nuance change over time? And so you'd need more intensive assessments if something is changing very rapidly over time. So you can absolutely use TVEM if you had, say, 5 time points, everybody measured at time 1, 2, 3, 4, 5, and you thought there might be some gradual change over time. Sure, you can estimate those models using TVEM, or you could do some sort of growth model, latent growth curve model, and just specify that time as a linear function of time, and that would also be just reasonable. But when things are changing more rapidly, you'll need more time points. And then I guess if everybody was measured on a different cycle, longitudinal data collection happened at different time points for different people, that's totally fine. What under the hood here is spline-based regression. And so, you can think about it conceptually like there's a moving window across, and you need to have some coverage of your time axis across all the periods of interest. And if there is a lack of data at some particular time window, then the confidence intervals will be much wider. So the confidence intervals that the software produces, this is in response to Elena's question, the confidence intervals are pointwise confidence intervals. So we're not taking into account the fact that we've got time varying significance testing happening. It's really like, because it's continuous time, it's really infinite. And so, you can fall into a trap of, over interpreting coefficients, but there is we rely on model selection techniques to help us balance models that are complex enough that they fit the data well, but they're simple enough and parsimonious enough that they may be able to replicate in another sample. So we really rely on information and criteria to help us not overfit our data. Terry, you're free to ask your question. There we go.
Yes. Hi, Stephanie.
Hi, Terry.
Great talk. You showed us that longitudinally intensive data from the Wisconsin study, right, where every day you had 4 or 5 measures of both craving and
Affect.
affect, right?
Mm-hmm.
And so it's kind of easy to imagine, you could in that study, even on a day-by-day basis, right, fit a model of affect as a function of craving. And then you could take all those models and you could look at all the intercepts and all the slopes, right? And then you could come up with some kind of function. Is that essentially what TVEM is doing under the hood?
So at first what I thought you were going is I thought you were going to say that you could do a within day kind of trajectory and then you could sort of like average across them. But it's more, I think the answer is yes to your question, but so so you've got data around that time point when that coefficient is being estimated on both the outcome and potentially predictors. And so it's using information in the region around that time point. But really, like the simplest way to think about what's happening under the hood, I would say is if you're just like if you're messing around in a scatter plot in Excel and you want to estimate the curve, you can estimate linear splines that approximate the data shape across the scatter plot. And so it's spline-based regression. So that's what is happening underneath the hood. Now, what I think you're asking a little bit is if you could estimate the coefficient of like the correlation between those two things in day 1, in day 2, in day 3, in day 4, and so on, and then smooth across them, that is definitely the nature of what TVEM is doing, and the result will look similar visually, but we're not just connecting the dots, right? We're really balancing model fit with parsimony to try to come up with the optimal model.
Thanks very much. Very nice.
Absolutely. All right, let's go into our second example then so we can get through this one and I can share some resources at the end. So in this study, instead of thinking about intensive assessment, and I should have said as well, the nested data structure is taken into account depending on the estimation technique you use when you specify your model. We do adjust the standard errors for nested data. So I should just say that because we're going to now leave the intensive longitudinal data world and think about things from a more developmental perspective where we're just thinking about people aging over time, but we're actually going to use cross-sectional data here, which is a little counter to how we think about time, but let's take a look at it. So vaping among adolescents is really quite popular now, even though vaping products were designed as a reduced harm product and thought safe, and their perceived risk is much lower in adolescents compared to combustible tobacco products. But there, people are wondering, and a lot of studies have investigated whether vaping becomes a gateway to traditional cigarette use. I think it's not exactly the case for a lot of people, but I think it's a gateway to other things like vaping, cannabis, and so on. But in this study, we pulled data from a national repository that was collected and designed to be nationally representative of youth. It's called the National Youth Tobacco Study. So we pulled one wave from 2014, cross-sectional data from the CDC, and they asked individuals, youth, all sorts of things about tobacco use and tobacco behaviors. So we have this large data set, 22,000 youth, ages 11 to 19. So all of middle and high school, and collected to be representative of middle and high school kids in the US. 49% female, and then a fairly diverse sample. And we wanted to answer these two questions. Can we estimate disparities in the rates of use of cigarettes and of vaping for different sex and race ethnicity subgroups, population subgroups? So just estimating the rates of use as a continuous function of age. So I didn't say that very clearly, but we want to estimate rates of use as a continuous function of age, letting the shape be whatever it is in the population. So this is very exploratory. And does that differ across sex and race ethnicity? And then second, we wanted to see whether the prevalence of use of both combustible cigarettes and vaping varies as a function of age through adolescence. And so we want to see the linking between vaping and combustible cigarettes, and how often do they co-occur over age. And so these simple analyses were presented in a kind of a didactic paper in Addictive Behaviors. Okay, so this is where the measurement gets really simple. So this is fun. We pulled this large cross-sectional data set. We have a binary variable. An indicator of whether they smoked cigarettes in the past 30 days? Yes or no? 6.4% said yes. We have another binary variable. Did they vape in the past 30 days? Yes or no? 9.2% said yes. These data are a little bit old. We have a single variable for age, which is going to be what we use for our time axis. And we have an indicator for sex and indicators for race ethnicity. So 4 variables, cross-sectional data. So, well, we had a weight variable as well. I didn't list there. So again, coming back to our model specification, the question is, what do we think varies with age? The probability of cigarette use certainly will be different. It will increase with age. The probability of vaping will increase with age. Do we think that the sex and race ethnicity differences or disparities across these groups vary with age? We didn't know. This was exploratory, but we wanted to estimate those differences as a function of age to see. And then the link between combustible cigarettes and vaping, does that link, the effect of one on the other, vary with age? Now we have a binary predictor of one type of cigarette use and a binary outcome of another type of cigarette use. So we're going to be looking at an odds ratio. Okay, so here is an example model that we fit. So now, because we're predicting combustible cigarette use as our outcome, we now apply the logit link function, and we're predicting the logit, or the log odds of cigarette use in the past month as a function of an intercept and the effect of sex. So this equation, this is a simple equation, an intercept equation to estimate the prevalence of cigarette use over age and whether there's a difference for males and females. And the age is our time variable, remember? So we want to see whether the cigarette use prevalence changes with age and whether that looks different for males and females. Similarly, we're going to step to our second research question, where we'll be looking at the correspondence between combustible cigarette use and e-cigarette use. So if you use combustible cigarettes, are you more likely to also vape? Okay, so we had those tiny 4 little variables. One of them was age, which is our time variable. And we're actually able to kind of shed a lot of light on how these things look over time. So we had a large sample, remember, so we had pretty good coverage of our age axis. So what do we see here? So first we're looking at sex differences in the prevalence of e-cigarettes and in the prevalence of combustible cigarettes. So 2 separate models, and we're looking at ages 11 to 19. And so what do we see? Well, certainly we see that the prevalence among males for vaping is significantly higher than the prevalence for females between ages 14 or so and about 17 and a half. So we see the age window during which the prevalence is higher for males. And we see almost the exact same thing about 15 and a half years old to 18 years old. We see that the prevalence of traditional smoking is higher among males. So this is really just looking at population prevalences. We're just doing it as this flexible function of age, which I think is from an epidemiologic perspective, a little bit more informative than a point estimate. Okay, this was interesting to us. If you are a substance use researcher, historically, you know that Hispanic rates of use fall somewhere between those, Hispanic youth fall somewhere between those of Black youth, which is lower, and white youth, which is typically higher. But when we're estimating these things as a function of continuous age, we saw that in young adolescents in middle school, that Hispanics had a higher estimated rate of or prevalence of vaping compared to white or Black youth. And then in high school ages, Hispanic and whites converged, and Black youth had very relatively low rates of vaping. And then for traditional cigarettes, we saw basically the same thing in early adolescence, that Hispanics had a higher estimated prevalence, but only around ages 12 and 13. And then whites really took off, and traditional cigarettes became more of a white youth phenomenon for those kids who are over 15 to 18. And we see just what we normally would expect to see in epidemiologic data, is that the Hispanic youth rate is right there sandwiched in between whites and Blacks. But because we had the age range and we looked at it in this creative way, we saw this interesting early adolescent blip here for Hispanic youth. And then kind of circling back to our final question was the correspondence between cigarette use and vaping. So going back to the full sample for a moment, now we've got really wide confidence intervals during young ages. That is because the rates of use of these substances are both very low for 11-year-olds, which is a good thing, leads to very wide confidence intervals. But what we get is the correspondence between this behavior and this behavior is expressed as an odds ratio. And the odds ratio is a continuous non-parametric function of age. And the interpretation would be something like this. So at this point in the curve, where the odds ratio is estimated to be among the highest, so we might say something like this. Among those age 12, these are US adolescents, among those age 12, adolescents who use e-cigarettes are more than 40 times as likely to use traditional cigarettes compared to 12-year-olds not using e-cigarettes. And so the risk of combustible cigarettes is 40 times that if they're also vaping, if they're vaping. And so we see the correspondence. Of course, we expected this to be a positive association. We knew it would be. The question is, how does that vary across age? And the smallest odds ratio is still about 10 here in the later adolescence. So again, with those simple 4 variables from a cross-sectional data set, we were able to think more developmentally with our data and in an exploratory way. And we were able to identify key ages of risk. Hopefully that could inform the thinking about at what age we might intervene and how. We see that traditional and e-cigarette use go hand in hand, of course, particularly in very early adolescence. And we also had this unusual finding or unexpected finding that early use of e-cigarettes was significantly more likely among Hispanic youth, suggesting that because they're younger, when we assessed, it was cross-sectional data. So does it mean that older Hispanics didn't have the elevated rate? Yeah, at that year, but those cohorts were going to age into high school. And so the potential for greater disparities between Hispanics and whites in the future exists. Okay, so those were the 2 examples. I just wanted to give you a flavor. If you've got data lying around, whether it's cross-sectional, longitudinal, intensive longitudinal, it doesn't matter. You might be able to find a tool like TVEM can kind of bring new life to a data set or answer some questions that are a little bit more exploratory or a little bit more nuanced. If this is of interest to you, some potential resources. And question about the Hispanic youth. So this was a CDC conducted survey of Hispanic, well, it was a nationally representative sample of adolescents in middle and high school. I think it's about their present, do they presently identify it as Hispanic? Like, so I couldn't say more, but yes, all states from the US. And I believe that study's ongoing, so it would be pretty interesting to pull a more recent data set, look at how they measured things more carefully, and see if the findings replicate, or if in fact we see that Hispanic use is elevated now for the older adolescents. That would be interesting. As far as resources, so as I said, we had a special issue in nicotine and tobacco research in 2014. Some nice examples there. We have got, I think, 2 or 3 of our papers were in that special issue, unpacking using TVEM to look at smoking cessation processes in an RCT. So that those could be good resources if you have a study design like that. Most recently, my lab was commissioned to write an article for addiction, and they wanted us to introduce time varying effect modeling when analyzing intensive longitudinal data. In this case, there was no randomized trial, but we were looking at changes during recovery. And so Sam Stahl is my student in BBH. Was lead author, and that just came out. So we're really happy for that. And the appendix has all of the code that we use for those models. So if you're looking to apply TVEM to intensive longitudinal data, that would be a good resource. There's a paper that we presented in Psych of Addictive Behaviors in 2016, and I like to call it TVEM 4 ways. We took the context of cannabis use in the US and we unpacked 4 different questions using TVEM. One that looked at changes over historical time using repeated cross sections for monitoring the future. One looked at developmental time or age, like we did with the vaping example. And one that, it says historical time twice there. Developmental time, historical time, age of onset. This should be age relative to an event is what the 4th one should be. So age of onset, since you started doing one thing, that was time 0, how long did it take until you started to do something else? So thinking about time relative to onset, and then thinking about time relative to an event, which we used the birth of your first child as the event. And then we modeled developmental changes prior to and after the birth of that first child. So again, TVEM 4 ways, not intensive longitudinal data. That would be a good resource potentially. Our lab, the AIM lab at PSU, we have a lot of introductory material on TVEM, introductory videos and such. There are materials if you're interested in teaching a seminar, like one class in a grad seminar on TVEM. We've got materials prepped for you. You're welcome to use. The book that Ashley and I published in 2021, you can get to it from our lab website. And every figure that appears in the book, and all of the results are figures, as you might guess. We reproduce on the website the figure, title, the equation of what were actually specified and how we specified it in SAS. So you'll see every single example worked out on the website. It's a great resource for the SAS code examples. And in conclusion, TVEM holds potential to learn something new from national epidemiologic data, long-running repeated cross-sectional studies, longitudinal panel studies, intensive longitudinal data, or, as I alluded to earlier, maybe time isn't even time at all, and it's some other variable. The computer doesn't know. We're just feeding it a variable and saying, treat this as the time variable. In one paper that my colleagues and I worked on, our quote unquote time variable was actually, we specified it as the number of drinks that you had during your heaviest drinking occasion. And so we were estimating the prevalence of alcohol use disorder for men and women as a function, non-parametric continuous function of not time, but number of drinks. Great. So I think that's, yep, I just want to do a shout out to my close colleagues right now, and Renzi for his historic contributions. There was a question about the DEI perspective. Youth self-identified as Hispanic. So yes, so I don't know how the CDC asked the question about Hispanic in 2014 when the data were collected, but I completely agree about the person-centered language. Thank you for pointing that out. Yes, and they were select all that apply too. So excellent. Other questions? A minute or two here.
Yeah, and if you have questions, you can unmute yourself and actually ask.
Terry, I see your hand is up, please.
Yes, so you said earlier that you use splines and you adjust standard errors. So I take it there's no person-specific random effects, right?
So there's a version of TVEM that does, the most popular version, I'd say, does sort of a general estimating equations approach, gets sandwich standard errors. It's a function of time.
Sure.
There's also a version that you can get random effects, and you can get random effects at the person level. But I think that I think it's limited in how much you can do with the random effects. I think because it's a population level, it's really like a marginal model. So I think that the kind of GEE approach to estimation to me makes the most sense. If you're going to have weights, then you've got to do a different kind of spline basis. So there's the B-spline. There's a penalized likelihood spline, a penalized spline function that you can use if it's just adjusting for the clustering, but you don't have weights. So there's a technical user's guide available where you download the software that will explain the B-spline estimation and the P-spline estimation. But I recommend when people get into it, do the P-spline, the penalized spline basis first, because you don't have to do a manual model selection. And then if you need to add weights, you can refine your models.
Oh, wonderful. And you showed us that it can do linear regression and logistic. Can it do count models also?
You can do count, but zero inflated is limited, I'll be honest. Yeah. Mhm.
Okay, thank you so much.
Yep.
It's a wonderful resource.
Good. Glad to have you, Terry.
I had a quick question about the idea, like, is there a way to estimate like the region of significance? So like my guess is in a practical sense, you wouldn't overinterpret one time point where the confidence intervals are non-overlapping, let's say between placebo and control. So is there any consideration, you know, with the idea that they're non-independent time points, things like that, where you have a guideline or a way to model like the number of contiguous time points that you should have as being showing like a state of significance? So
yeah, wow, great. Yeah, really good questions, Elena. Yeah, no, I would say, but so over, you know, whether or not the confidence intervals are overlapping between treatment and placebo, or treatment and control group, that's a nice graphical, you know, eyeball way to do it. But really what you would do is put in a coefficient for treatment group, and then that coefficient for treatment group, and as a function of time, is what you would rely on for this hypothesis testing. Is there a region of significance approach? No. So you know, so we wouldn't want to overinterpret the exact endpoints of that region of where it's statistically significant. You know, you have to be careful not overinterpreting it. And of course, like any statistical model, if we had twice the sample size, the region gets bigger. So, you know, it's tied into statistical power, of course. Yeah.
Okay.
All right.
Thank you very much.
Thank you, Pravani. Thanks for having me, and enjoy
It's a
this
great
beautiful
talk.
day, everyone.
Yeah, thank you everyone. And as a reminder, you will receive a link to the video, recorded video, as well as the slides sometime later this week. Thank you again, Stephanie. It was a great talk.
Thanks, Pravani. Have a good day. Bye, everyone.